In this section, we will discuss a little more about the concept and any other details about these experiments. So, as we mentioned before, the title of this experiment is Stefan's Law Experiment with a Light Bulb. So, as an introduction, have you ever observed and wondering about a light bulb? When a light bulb shines so brightly, can we see through where the lights come from? The electric current that passes through the filament makes the wire getting hot and producing light. In daily life, heat is often used in many technologies. For example, the heater in incubation or infrared heater in any industrial sector. You can search any other example for this. To use the heat that was produced, we need to know the characteristic of the bulb in producing the heat. Hence, we're gonna investigate the relation between electrical power and absolute temperature of the filament itself, which follows Stefan's law. And also, as we mentioned before, the goal of these experiments are, first, to investigate the validity of Stefan's law in the bulb filament, and second, to find any relations between bulb electrical power and the absolute temperature of the filament. So, we will talk a little more about the basic concept of this experiment according to the theory. Light bulbs are made from filaments that shine in high temperature. Because the resistance of filaments are dependent on the temperature, it makes the value of the resistance between light off and when the lights on the warm temperature are different. Equation that connected these quantities given by equation number 1, as you can see on the screen. You can see that the resistance are equal to the temperature with the power of 1.2, with R273 resistance at the temperature of 273 Kelvin and the constant for specific resistance. Then, the relation between the resistance and absolute temperature can be written as the equation number 2, as you can see on the screen. You can see that the resistance is proportional to the absolute temperature with the power of 1.2. A light bulb itself can be considered as a black-body object. A black-body object is an object that can transmit and absorb any heat perfectly with the emissivity of 1. Or we present in E. Stefan's law statement for radiation energy rate of black-body object with emissivity of E and surface area of A and absolute temperature of T can be written as equation number 3, as you can see on the screen. The differential of energy to the temperature are equal to power. The formula of the power itself is a surface area times a Stefan constant times emissivity times absolute temperature with the power of 4, with the value of the constant of Stefan is this. When the filament that has a resistance R and the flow electric current I, power that dissipates R can be written in the equation number 4, as you can see on the screen. The power are equal to the electric current square R and proportional to the absolute temperature with the power of N. From equation 2, we can rewrite the equation 4 to equation number 5 like this. You can see that the electric current square are proportional to R with the power of N per 1.2 minus 1. From that equation, or equation number 5, we can make a graphic of logarithmic of the electric current of I versus the logarithmic of resistance of R. Then, we can find the gradient according to this equation, equation number 6. The gradient of N are equal to half of N per 1.2 minus 1. Hence, we can find the value of N, the power of thermodynamic temperature. The apertures that we use in these practicums are 1. 3 bulbs in experiment board. There are 60 watts, 75 watts, and 100 watts of power as a light source. Then we have a voltmeter in experiment board to measure the voltage of the circuit. We have a milliampere meter in experiment board to measure the current of the circuit. Variac as a voltage source. In this case, we use a generator, connector wire, and pipe to cover the bulb. The set of these apertures, we can see it in the figure number 1. The method that we use to get data for these experiments are like this. First, set the apparatus as shown in figure 1 before, and let a 60 watt bulb be connected to the board. First, we use the 60 watt bulb. Set the voltage with the variac. The range of a voltage in this experiment is 50 volts until 200 volts with 10 volt interval. It means that we start from 50 volts, then 60 volts, 70 volts, and so on until 200 volts. Cover the bulb with the pipe. Then, for every rise voltage shown by voltmeter, we note it as V, and current that flows the circuit shown by milliampere meter, we note it as I. After it reaches the highest voltage, or 200 volts, set the voltage back to 0 volts with a variac. We repeat step 2 until 6 with a different electric power of the bulb, with the other two power bulbs, 75 watts and 100 watts.
Halo teman-teman, pada kesempatan kali ini kita akan melakukan percobaan dengan judul eksperimen hukum Stefan pada kawat pijar lampu listrik. Adapun tujuan dari percobaan ini adalah untuk menyelidiki keberlakuan hukum Stefan pada kawat pijar lampu listrik, yakni hubungan antara daya lampu pijar dengan suhu absolut dari kawat pijarnya. Adapun alat-alat yang kita gunakan pada percobaan kali ini adalah lampu dengan 3 variasi daya untuk variasi nantinya. Ada lampu 60 watt, 75 watt, dan 100 watt. Kemudian ada variak sebagai sumber tegangan pada rangkaian, ada ampermeter, ada voltmeter, ada kabel, dan ada pipa sebagai penutup lampu pijarnya agar panas dari lampu pijarnya yang mengenai kita tidak terlalu banyak. Pertama-tama, kita rangkai alat dan bahannya sesuai dengan skema ini. 3 rangkaian ini merupakan variak. Kemudian variak kita serikan dengan lampu. Kita gunakan lampu 60 watt terlebih dahulu. Kita serikan. Kemudian lampu kita serikan lagi terhadap ampermeter. Dan ampermeter kita hubungkan dengan variak secara seri. Untuk voltmeter, kita hubungkan secara paralel voltmeter dengan lampu. Seperti ini. Setelah semua rangkaian terpasang, jangan lupa kita pasang juga pipa pada lampu pijar. Kemudian kita nyalakan variak generatornya. Kita atur tegangan yang mengalir pada rangkaian hingga 50 volt. Setelah tegangan mencapai 50 volt, kita baca arus yang mengalir pada rangkaian. Sekiranya ini 115 mA. Kita naikkan tegangannya 60 volt. Kemudian kita baca lagi arus yang mengalir pada rangkaian 125 mA. Nah, ini membuktikan bahwasannya semakin tinggi tegangan, maka arus yang mengalir pada rangkaian juga semakin tinggi. Kita lakukan variasi tegangan yang mengalir pada rangkaian hingga mencapai 200 volt dengan interval 10 volt. Dan jangan lupa kita lakukan variasi terhadap lampunya dari lampu 60 watt, 75 watt, dan 100 watt. Sekian percobaan dengan judul eksperimen hukum Stefan dengan kawat pijar lampu listrik. Ingat ya teman-teman, kita melakukan variasi tegangan untuk mendapatkan arus yang mengalir pada rangkaian, dan juga kita memvariasikan lampu untuk mendapatkan 2 data selanjutnya. Sekian dan terima kasih. Selamat mengerjakan laporan.
Okay, so in this section, we will talk about how we analyze the data to get the result that we need according to the goal of this experiment. So in this experiment, we use Ohm's law, measure the resistance for each data of voltage and electric current. From the equation number 5 before, we get these equations, and we use the logarithmic rules to get these equations that are proportional to the equation of line that we use to draw a graphic. So the y data are represented by the logarithm of electric current or I. The x data are represented by the logarithmic of the resistance of R, and the gradient of the line that we draw later is represented by this equation or expression, a half of n for 1.2 minus 1. So you need to draw the line based on these equations. Remember, the y-axis are this, the x-axis are this, and when you get the gradient of the line, you can get the n value. Compare the n value from the calculations of the gradient with the exponents of the temperature of Stefan's law from the theory that we learned before. And don't forget to do the calculation of the other two bulbs. Remember that we have the 3 bulbs as the 3 variations. So this is the observational data that we get, and you will use this to get the result. As you can see that this is the 3 sets of data for each lamp, 60 watts, 75 watts, and 100 watts. And so this is the voltage as the slide.